Lesson is on graphing imaginary numbers. I know many of you don't like graphing, but this graphing is actually going to be a lot simpler than you actually think. In all the math you have done before, we have the real numbers, and that's defined on the coordinate axis where we usually have x and y. But now we're going to have the complex numbers, and this is going to be the complex axes. So it's very similar, but now this is considered the real axes for the real numbers, and the one vertically is going to be the imaginary axes. So what does that mean? Well, let's graph some, for example. And in math for complex numbers, again, we use the letter Z to denote the complex numbers. Let's try 4 plus 3i. Think of it as a y equals, but now since we're using complex numbers, we are using z equals. So this is the real number, and this is the imaginary number. And remember that this is the imaginary axis, and this is the real axis. So to graph, all we do is we go over 4 spaces to the right. So that's 1, 2, 3, 4. And we're going to go vertically up 3, 1, 2, 3. So this is our graph of z equals 4 plus 3i. All it is just a dot. Let's try z equals -1 minus 5i. So we're going to go -1. Think of this real number as an x. And this is our imaginary number. Think of it as a y. So if I go -1 to the left, I go 5 down, this is my answer. Let's just try a couple more. So 2 minus I, so that's 2 to the right and 1 down, which is right here. What if I give you z equals 3i? Well, there is no real number, so that'll be 0. And my imaginary number is 3, so I'm going to go up 3. So there's my point. Let's try 3 plus 4i. That'll be 3 to the right and 4 up, which is right there. So to expand on the graphing, let's go back to that example we just did. When we ask for the absolute value, the way we write it is z equals the absolute value of z equals the absolute value of 3 plus 4i. Well, what does that mean? Well, on the graph, that point was right here. Remember, the absolute value in math terms means distance from 0. In this case, it's the distance from the origin. So really, I'm looking at this distance here. This is the absolute value of z. Thinking back to geometry, I can make a right triangle from this. And you could think of our distance formula. And the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared, which basically is the same thing almost as the Pythagorean theorem. Which is a squared plus b squared equals c squared. So if I look here, think of this as my a, think of this as my b, and think of this as my c. So the distance here for my a is actually 3, and my distance for my b is actually 4. Now if you look, this number is basically our imaginary number, and our a number is actually our real number. So once you see this, hopefully you can do it without graphing. So if I'm using Pythagorean theorem, that will be 3 squared plus 4 squared equals c squared. And if I solve this, that would be 9 plus 16 equals c squared, 25 equals c squared. If I take the square of both sides, c is positive 5 only because we're talking about distance. Distance is only positive. So that means the absolute value of z is 5. And remember, z is 3 plus 4i. Another thing to notice or to know is that in math, we use the term modulus when we talk about the absolute value of z. So let's try one, and we don't need to graph, but I'm just going to sketch a graph. So the absolute value of z of 7 plus 2i. So if I sketch my graph, my thought would be about there. And again, finding my distance, and if I create my right triangle, this would be 2, this would be 7. And I'm basically looking for this right here, which is c. So 7 squared plus 2 squared equals c squared. 49 plus 4, that's 53. If I take the square of both sides, I prefer keeping it with the square root because there is no square root of 53, that's a whole number. If you want to change your decimal, you can, but I'd rather have you keep it as the square root of 53. Let's just try one now without graphing. So the absolute value of 8 minus 6i. So again, think of this as your A, think of this as your B, and we're looking for our C, which is really this right here. So that's going to be 8 squared plus negative 6 squared equals C squared. 8 times 8 is 64. Negative 6 times negative 6 is 36. 64 plus 36 is 100. If I take the square root, C equals 10. So to recap, when we're graphing, again, this right here is basically your real number. Think of it as X. This is your imaginary. Think of it as Y. So X, remember, is left and right. Y is up and down. And if you graph it, it should just be 1 point, 1 dot. And if we are finding the absolute value, then it's really just the Pythagorean theorem. Again, this means absolute value. And you can use a distance formula, but it's a lot easier if you just think of Pythagorean theorem. That's the lesson. That's it.